essentially, TorchGeo is a wrapper around PyTorch if you want to do geospatial analysis or geospatial ML. So it abstracts a lot of things here already. So you don't need to worry about what's the coordinate reference systems and so on. So it already abstracts those. So I created a Jupyter notebook for it, wherein it does the usual segmentation. So for example, for this one, you have an RGB image here, and you want to detect all of the what we call classification for this one. So for example, this is, I think, a road, a river, and so on. So you can do your own training for those. Yeah, essentially it's just a good wrapper around around geospatial and data sets for, especially when you're doing ML. And it's basically Torch under the hood. So if you're going to look at it, it's just Torch. Basically, that's it. Done.
Nothing
Yes.
goes planet. My name is Kirill Tribunskii. I work in Salmon. I arrived to Philippines not so far ago, and I'm going to tell you about some Python in Fintech startup. So all you know what the Python is, and I don't think that you know what is Salmon. Salmon is Fintech startup with very professional team of both technicians and finance experts. And there are some more interesting facts about our company. You can read it here. But I want to give you maximum about technical stuff of Python in our team. Uh, Me, especially just a regular Python developer, I'm not an ML engineer and so on, just doing some ML ops in our company, and our team is great because we have a different experience in different fields, in different domains. Many of us have some experience in steel industry, and we use modern Python with different frameworks which we choose by our tasks. The most significant things that we did in Salmon, you should understand that this is finance, this is Java, this is bloody enterprise in future, I hope. But machine learning we do in Python, such as non-critical, non-transactional services, which are possible to make in Python to free Java team, for example. So we developed parts of Know Your Customer system. This system is used to verify clients and prevent fraud. We developed our own OCR solution to scan documents and recognize text in it. And we also do some embedding search. We also do some risk model, but it is too difficult to explain in 2 words, so I'll just skip it. So what is interesting about our KIC is that it's powered by Postgres, and it has extension for vectors, which is called PegaVector. It was written by Andrew Kane. He's a great engineer, I think, and it hardly uses Postgres native types to store vectors in it, and it makes Postgres solid vector database for searches. We have more than, we have hundreds of thousands of embeddings to search with, and it is a difficult computational task when you try to fill your database dynamically. So we use it. It works quite well. We are going to use some approximate search indexes in the future, but now we just do full scan, and it works fine, scalable, and fine. We also developing now a second factor for authentication via the similar idea of comparing faces on the photos. The main problem with it is the machine learning model should extract features from photos, and multidimensional vectors should be distributed in space in such a way that more similar faces should be represented by proximate vectors. So we are going to use hierarchical index for this task in future when full scan will be too slow. Hierarchical search is very stable co- compared to a flat inverted list. And we are going to enable A/B testing in our models because now, right now, it is just one working model, and the problem with such RAG systems is that when you migrate to a new model, you need all your old data to be produced by new model. So you should deliver it in place, all new generated embeddings with different properties from our first model, and so on. So this is canon search, blah, blah, blah. And yes, and we really use Python in finance. This is fun and great. And if you have any questions, you can reach me after this presentation.
So, hello everyone. My name is Jabez Borja. So, I will be giving a talk about decorate your life with Python. So, what exactly is a decorator? So, well, it's actually that as the title says, it's not actually we decorate our life, but we are diving in Python decorators. So, in Python, a decorator is a design pattern that allows you to extend or modify the behavior of functions or methods without changing their code. So think of it like wrapping a gift, and you add an extra layer without altering the essence or what is inside the gift. Okay, so decorators are used at decorator syntax. So you place them above the function definition as they alter the behavior of that function. So it might sound abstract, but let's break it down with an example. So decorators are, in essence, functions that take another function. Take another function as an argument, add some functionality, and then return the modified function. So this is a higher order function concept. It's fundamental to understanding decorators. So in Python, everything is a data type. So even functions are data type. As you can see that I pass a function itself, and then I can run that parameter or an argument to my function as a data type. So it's I can pass to a function. So what are the practical uses for decorators? So well, let's explore some practical uses. Decorators are commonly used for logging, timing, access control, and more. So for instance, a simple timing decorator could look like this. So we have an example here, I hope can be seen from afar. So we have a really, really slow function. So as you can see, we have my slow function right here. And then let's just say this function, like that fetches from database and from another server. But we'll leave it as is that we are sleeping the code with time.sleep. So what I want to do here is that I want to count how many seconds did the code run. So I use a decorator, timing decorator right here. So you define a decorator with also a function. So here I have a timing decorator that passes my slow function itself. So as you can see, if I had a timing decorator right here, so this function is this func. And then there's a wrapper because the decorators requires you to have to return a function, so it will run. So here is our decorator, and we are setting up a time right here, and then the result, we are gonna run the function, which is this one, and then end the time, so we calculate the end time, so we can calculate the what is the time of the execution of that code. So great job. So that is a Python decorators in 300 seconds. So yeah, thank you.
Hi, my name is Justin. So my website is that QR code right there. And my presentation is the FIR coefficients as weights, or how to approximate effects, audio effects through machine learning. So to start, let's say what is a sound? Well, a sound is created by a vibrating object. And it's a wave that travels through different mediums, let's say air, water, or really any solid. These waves eventually reach our ears, which allows the brain to perceive it. And as a wave, it has two important components, which is the amplitude and the frequency. Digitally, we store sound through a process called sampling, and it is done by taking the amplitude of the sound at a specific timestamp. And that amplitude usually ranges from 1.0 to negative 1.0. In audio, specifically digital audio, we usually talk about audio signal processing as well. And it's a process of manipulating audio signals. So think audio synthesis or maybe music production. Usually you modify the audio signal to make it sound something that is worth listening to. But in analog, processing is usually done by directly modifying the electrical signals, while digitally processing is done using the time domain representation that I showed earlier. Filters are algorithms that are used to modify a signal, and they're characterized usually by the frequency response or how different frequencies affect, or how the filter affects the different frequencies in the sound. And common filters include low-pass filter, high-pass filter, band-pass filter. So the low-pass filter, usually this is when the bass frequencies are articulated. So kunwari, lumabas ka ng room. When you exit a room, when there's music playing, you're only gonna hear the bass, mostly. And then bandpass filter, this is actually used for Wi-Fi as well, with like separating the frequencies from the 2.5 gigahertz range. So I want to talk specifically about finite impulse response filters. Don't be scared. It's just a formula I have code. So it's a type of filter, and it can be expressed with this formula. But specifically, I want you to focus on the B0 and B1, which are coefficients. And audio effects, such as the filters I mentioned, are designed by finding desirable values for these coefficients. So here's a code example. Medyo malabo, but see, I defined a contrived filter with 3 parameters, which is the coefficients. I assigned some properties, and then I put a process function, which defines sort of like how to actually process the signal. And basically, this has a memory, and that memory is the previous samples that was passed to it. And you can see there's also a dunder call, which is just nice syntax. Then, if we use this filter on a sine wave, you can see the blue wave is the original audio, and the red wave is the processed one. And these may seem familiar because FIR filters are actually convolutions, and convolutions are used in machine learning. And here, I define a script that proves that the filter I just defined is actually a convolution, and there's this assertion right here that says torch all close, then it just compares the 2 signals that I produced, and it also produces this graph. Hindi kita, but you can see like the black dots align with the red ones. In practice, this is used for modeling, like machine learning models, and the FIR filter is usually just here. All this other stuff is just like machine learning. Then you can also have products based on this idea, such as the neural DSP, quad cortex. And for further reading, I suggest looking into IRRs, or infinite impulse response filters, and looking into how they relate to LSTMs. So sources, and special thanks. Thank you to ChatGPT for generating the... No. Thank you for generating the math, because I'm not familiar with it entirely, although I did work with it. And of course, the convolution cadence crescendo team, which was my previous team that I worked on here. And yeah, for any questions, just contact me here. Thank you.
So, okay, let's start. Sige. Hello, everyone. I'm Chris. I'm from UP Resilience Institute. Today, I'll be talking about our work. It's a citizen science network for detecting earthquakes. Who among here has ever experienced earthquake? Right? Okay. So here in UPRI, we created an IoT network that is detecting earthquake. Okay, so here's what I'm going to talk about today. First, I'll give you an overview of what we do. Then I'll show you our high-level service that some of you might be interested in. Then our low-level service, we have a lot of data available. And then finally, some useful information for everyone. Okay, first overview. So this is our network. I mentioned that it's a citizen science network. That means it's operated mostly by volunteers who are interested in maintaining a sensor. Another thing, this is that we're using low-cost sensors. Those are Raspberry Pi sensors. So instead of the typical expensive institute-grade ground motion sensors, we're using very, very cheap Raspberry Pi devices. And lastly, this is a fully open source system. Everything is available on GitHub. And if any one of you wants to deploy the same system from the device to the servers, you can just clone our repository. For those who are interested, this is our software stack. Some of these are written in C, some are written in JavaScript, but most are written in Python. Okay, so here's our high-level service. Just want to show you. So this is our web app. Okay. Oh, so luckily we have here some ground motion going in. Yeah, and this here is live data, and here on the left are the earthquakes that are being detected. For example, this is from 2 weeks ago in Caraga, Philippines. It's a magnitude 5.3 earthquake. We also, since this is open source, we also have comprehensive documentation of our code. We also have tutorials. And yeah, so that's our high-level services. Next is our low-level services. We have real-time and archive data. On the left, you're seeing our data select web service. Here you can download a lot of ground motion data from the sensors. On the right, you see an example. So it's not yet processed. That's why there are a lot of gaps. And also, we have a real-time data. You can connect with it, port 16000. Okay, some useful info. You can use OBSPy if you want to use our data. This is a Python framework for seismology. And also, we give away free sensors to those who are interested of maintaining a sensor maybe in their homes. So just hit me up here in the email I provided, or talk to me later. And lastly, we are currently in the works of developing a datathon, which would start on September. We call it QuakeQuest. So it's learn, compete, and win. So it's a 3-month-long period where in the first month, we give a crash course to senior high students who are participating. And then they would perform a 2-month research creation. And then finally, they are going to present their research. And of course, there are prizes as well. For those who are interested, just hit me up. Thank you.
Hi, okay. Hi, I'm Marvin. This is unironically a talk about the print function. So, when I was a beginner, this is one of the first few codes that I was able to try. So, I'm not sure if you can read properly, but this is basically what it does. So, let's try here, right? So, this is written by Al Swigert, author of the Automate the Boring Stuff. It basically prints what the coordinates of your mouse. And I think this is awesome, especially if you look at the code. There is zero reactivity here, just some clever tricks, including string encoding. So apparently this /b is a backspace and some other stuff. So yeah. So this is usually the first print or the first Python code we all do, but we can actually apparently extend this print function into other functions such as flush. So flush enables your code, like what Al did in his code to actually print before uh, before the statement actually ends, especially if the end par- if the end parameter of your print is not a new line or the slash n. So also we also have the file parameter. So the file parameter, what it does is to basically emulate the append append file function in the bash. So if you want your print statement to actually write into a file, you can actually put a string here of the file name, or and it can also accept file objects. So yeah, so that's it. So yeah, so this is basically for most of my programming career. This is how I emulate a shell. But believe you not, there's actually work being done to actually improve the TUI, or the terminal user interface creation for Python apps. So Easy Deploy is now just not exclusive to web apps, but also through terminal apps. Right? So this is an example output when you type in Python-m rich. It showcases the ability of the module. Yeah, so with that, with this code and with rich, I was able to deploy specific multiple Python apps throughout uh, my career. Yeah, in fact, yeah, let me just. Anyway, let me just plug that, yeah, the Textualize company is actually investing so much in the rich ecosystem that they were able to create a now called Textualize textual framework by the Textualize company. So what it basically does is you set up your app in specific way, which is very similar to web apps. So they include certain headers like components they call widgets, and they also have introduced the concept of CSS in order to style the script. So yeah, isn't it wonderful? Yeah. So yeah. So yeah. So just to fill up the remaining time, yeah, I would like to plug to fix some bugs I have also encountered along the way. So yeah, that concludes my talk. Thank you very much.
All right. Is this working? Yes. I think it is working. So, hey everyone, I'm Dodi, fresh grad Paco, and I'm gonna just show you something I did as one of my projects for my computational physics class. Who here has taken physics or like any basic physics or mechanics class? Oh, not that much people. But anyway, let's just give you the rundown. You know how in force, you know, normally you would have the force equals mass times acceleration. It's a bit different if you're in space. If you're in space and there's one body orbiting another body, like the Earth orbits the moon, you'd have this equation. This force equation represents the force between one object orbiting another object. G is a gravitational constant. You don't have to worry about that, but anyways, you can who here has also taken any form of calculus? Okay, so you see, as you just to recap, acceleration is actually a derivative of velocity. That's why it's written like this. And this equation of force can be written in this manner. Now on to the spicy stuff. What I'm actually simulating here is the motions of two and three body problems. It is basically the simulation of two or three body objects in outer space. Let's start off with the importation of modules. Here's, you got the good stuff. You got NumPy, you got PyPlot for plotting because that's how we plot, and this is how we're solving all the differential equations. Now, this is, see, now, when I said that you could ignore the G's, I kind of lied because you need them anyways. You got the masses of Earth, the moon, the distance in meters, because somehow that's how Python works. Tapos you got this constant. That's why we had to put it in meters. We use these initial conditions to first form the foundation of our model. Then what we have here is the definition of the equations of motion. I know I didn't use any wrappers, but like I was kind of lazy and I had to finish this project. So we got these initial conditions in 3D because, you know, looking at 2D models is kind of boring. So we have these equations here in 3D. I know it's a lot, but anyways, it's a lot for me as well. I just graduated. In the end, we would have this model. You'd be confused why you would not see the Earth and the Moon. You see, this is just the motion lang. So the Earth wobbles a bit as the Moon orbits it. So that's why there is a motion. It is also not perfect because, as you know, the Earth orbits the Sun and there will be some fluctuations. To make this a bit more appealing, I added a function here to plot a sphere. We have here some mesh grids I used and I plotted them in the orbits. Don't be shocked. It's not a sphere, but what we have is a failed attempt at a sphere. But anyways, this is what it would look like, and that's how you know the model makes sense. Now, I would like to expand this for the sun. So we have the masses of the sun in kilograms. We got a couple of distances and times. We could ignore all of that. I think you all know this from basic math. We have these differential equations to calculate the distances between bodies because NumPy and SciPy would need that to give the arrays and show the model accurately. This is what we would get. The moon is actually orbiting along with the Earth because this is where the sun would be. But since the sun is so massive and so far away, we have something like this. And yada, yada, yada. Here's the sun. This is the Earth. This is the moon. The sun's actually pretty big. Yeah, the solar system's boring. Let's go somewhere else. What we have here is a model of a two-body problem. It's the same thing, but we just change the parameters a little bit. This is what it looks like. This is a two-body problem. However, it's not in the center of mass. That's why it looks weird. And the center of mass is just like an average. This is what it looks like. It looks a bit more beautiful. This is where the fun stuff comes in. What if we added a third mass of equal? It'll be a third mass that is equal to these two masses. Let's see what we have. We got this, we got these functions. I'll be honest, I barely know half of these. I was on caffeine when I did this. It's chaotic, right? The thing is, even to this day, most supercomputers have a hard time solving these free body problems because free body problems in their nature are hard to solve because they're chaotic. Anyways, that's all, and this is my sources because I don't plagiarize. Thank you, everyone. I'm not taking questions.
Hello, everyone. I'm Mark Anthony Estospace. So I'm a full stack developer at NStack. So right now, I'm also vice president for DevCon Community Tech Expert of the Philippines. And then, so yeah. So right now, Python is a very versatile programming language, so we all know that. So it is used for a wide range of tasks, so including web development, machine learning, artificial intelligence, automation, and much more. And since Python was always been discussed on those topics, then something pops out on my mind since I'm also a mobile developer and I do using different technology other than Python for mobile development. So how about Python? Does Python can do that as well? Yeah. So well then, so if you love Python and you're doing mobile before, so using other programming languages, so maybe you already know the framework behind for using Python for mobile development. So I'm introducing this one. Kiwi. So it's an open source Python app development framework, and it's likely around 16.7K stars in GitHub, but it was developed before, and it was around 12 years ago. Yeah. Yeah. So it's their site, so you can visit that one. Yeah. So how can we install Kiwi? First off, of course, since we are Python developers, so we always using virtual environment. So to install that, using Python or Python 3, negative NV and the project name, and then source bin activate to activate the virtual environment, and then install pip install the Kiwi framework. And then afterwards, these are the some sample code of Kiwi. So as we can see here, so Kiwi use widget. And if you are familiar with Flutter, so it's something like that. So Kiwi has widgets as well you can use. Yeah. So this is the sample output from the previous code. So how we can package our application. So here's a link. So if since there's a lot behind packaging your mobile application in either Android, iOS, and web, and any, yeah. And also Kiwi has this we call Kiwi Garden, and there's a lot of other already created framework based from Kiwi. Yeah. So that's it. Thank you.
Good afternoon, everyone. Hello, I'm Matt from Python Philippines. I've been organizing since 2013. Yeah. So, and uh, this topic is kind of like something that I've been thinking about for a while, like understanding the nature of volunteer-driven organizations and some of the ideas that we are playing around with on making this good thing last. Okay. So, just so to give you like a quick rundown of like the things that I've learned so far and maybe some of the ideas that I'm exploring. So, volunteers, life will get in the way of their commitments, regardless. So it's just the nature of things. So fighting that will only frustrate you. So don't. Create consistency within the org. Like communities will rely on you to keep this good thing running. So creating consistency by doing the minimum. This is something that we've learned. People will always have ideas, contributing, or rather want to do things, new things, but know what the minimum is. What do the community, or what is the most value you can provide for the community at the minimum? So this helps you roll with the waves of volunteers' lives, the varying commitments. It also honors your volunteers' efforts. If they work hard, you make sure that those hard work don't go to waste. And this minimum actually builds the momentum towards creating bigger things. So also one of the things that I've learned is because of that, we want to design programs that can be done with the least amount of people, as much as possible, but still create a platform where people can explore and create their own initiatives. So always be open. So this is something that I meant about life will get in the way. So if you're familiar with Maslow's hierarchy of needs, this is not a pyramid that you go up to, like this is essentially just I feel like this is more of a representation of what goes in our lives. Okay, sometimes we have time towards exploring some of the things like giving, love, and belonging. Medyo malabo pala yung picture, guys. So let me just read this very quickly. So physiological needs are the ones that, there. So physiological needs, we just need to like get fed, get sheltered. Safety needs, we want to make sure that we're safe, we're secure. Love and belonging, this is where we start looking for community that we want to belong in. Self-esteem, and then self-actualization, where we want to start contributing towards something greater than ourselves. And we always go through this waves in motion in our lives. So that's just life gets in the way. So we want to create consistency. And something that I've learned, so essentially, these waves is our volunteers' motivations. People will be motivated, they get demotivated, and then it's just like a wave of these things. So what we want to get at is, what is this blue line here? This is the minimum we want to do. It doesn't matter what happens in life. We just get things done. We provide value to our community. Still, and to do that, usually we encourage volunteers to champion their own initiatives. You have to be ultimately responsible for your projects, for your initiatives. If other volunteers can chime into that, that's good. Have a plan A for that ideal scenario. Otherwise, have a plan B if it's just you who's going to be working on that. So that's it. This talk is not complete. I'm still exploring other ideas, and I would love to hear your thoughts too.
Hi, I'm Juan from PyCon Korea and the Python Software Foundation. This is maybe a short story, but I just want to let you know. Yeah, what is PSF? Oh, I don't know. I didn't invite it. Or should I go there? Or just I just using Python silently. Nobody knows. I'm scared. Why do I meet some other guys, other peoples? It's just United States nonprofit. What? What should I know? Yeah, you are 200% invited. Yes, please. Yeah, you are. Everybody is invited who is using Python or want to invest Python or you want to make some trying. It's okay. Everybody is invited. Yeah, I just want to share about the Python 2023 survey's results. Yeah, maybe it's not published yet, but I show you some point. Please respond first. The total response is about 20,000 who completed the survey. But how many people in Philippines responded? Yeah. In US, 3,500 people responded. And in Philippines, just 15. They don't know you. You are here, but they don't know you. Actually, it's not different from Korea. Yeah, we have a little more, and China is a little more, but it's not. They don't know you are here. So, what is PSF? Yeah, PSF is just nothing. Without you. Yeah, we want you. Just I'm here, please. Yeah, just the PSP is just not a Python. PSP is not Python. PSP is just an organization, just the people who want to support the Python community. So we represent the Python, your Python interest. But there is no you. So please come out. So PSP is just two sections. PS board, who is elected with vote. Vote is important. Other thing is PSF staff is hired by PSF and paid by PSF, and they working for the homepage, PyPy, and other tasks like sending money, supporting community things. So, and there is developer in residence who is committing the Python code in the PSF. And so please connect and request more. At first, we should have money. The money is, yeah. You can search the PS annual report. How many money requested by the content? Yeah, please make assumption. There is no time, but I will talk. Okay, 1% in Asia. Actually, from the before COVID, there was 5%, but this is last year's. It was 1%. So how many Asians shown in the PS4? Yeah, only me. I'm the only one who live in Asia. Also, there is some other regions, but they are living in another continent, in the USA, Europe, or other continent. Yeah, total 4 of the us is Asian, but only me who lives in here and want to talk about you. So we should represent ourselves. You are here, but they don't know. We didn't invite you. No, we should go. So what should we do? Yeah, just buy the boat. Actually, they are democracy. You should vote. The vote will only represent you. How can I do? Just be a member who can vote. Yeah, it's this from the page and be a member. Just basic members is okay because basic members doesn't cost and it means you are here and they will know. And there is sustained membership they should pay, but it's really expensive by the year. And there is sliding scale membership is by the continent, by the payment. And this is what I should talk about. There is managing members. Managing members is by the community members. And contributing members by the commits. So please, if you spend 5 hours per month, please ask me how to do it. It's easy. And please contact me to make some changes. Please help me to represent you. Or you can represent yourself. Thank you.
Okay, hi, I'm Ted. I'm a full-time software developer at bukas.ph, and I'm a part-time cybersecurity researcher. Basically, I try to legally hack corporations for profit. Legally, right? Okay, so through bug bounty programs, so in HackerOne. Anyway, so I know this is PyCon, but I won't be talking about Python, unfortunately, so bear with me. But it is cybersecurity. Oh, so I found the remote code execution in a billion-dollar publicly traded company. So, yeah. In this particular CVE, which is a database of vulnerabilities, there are 4 things that need to happen. First, you need to find a website that is powered by Strapi, which is a Node CMS. Second, the super admin for this website is somehow has not been claimed yet. And then this has to be a particular version of Strapi. And then fourth one is critical. No other hacker should have seen this before. So the stars have aligned in my favor, and these things happen in this particular subdomain. So I have a server that pings me of new subdomains every 5 p.m. so I can check them after work. And then I found this subdomain, strapi.redacted.com. And then this subdomain apparently has their super admin registration not yet claimed yet. So I managed to log in and register. Boom, I have their super admin. So being a super admin is nice, but how can I make this even more severe? So I Googled the CVs for this particular technology, and I found out that there's a reverse shell exploit. So for this to happen, I have to prepare an attacker server somewhere in DigitalOcean. I'm not sure if you can see this. So I have Netcat listening to port 1234. So it's basically waiting for incoming TCP connections. So next, I have to prepare a reverse shell payload. I'm not entirely sure what this means. Actually, I just copied and pasted it somewhere. But I think if the victim machine runs this, it should it should spawn the bash shell from my attacker server. So combining this with the CVE describes this particular payload, which I don't actually fully understand. Actually, and then I inserted here somewhere. My attacker IP is in here, and then so if this runs, the exploit will run this whole thing, and then it should spawn a bash shell as root. So in this exploit, as a super admin, I saved the template in the email confirmation page. And then I just have to run a curl command while my server is waiting for TCP connections. So there, curl, and then once I run that, I've logged in as root in their server. So that's nice. So what's the implication of this vulnerability for this company? In the server, I managed to find their highly sensitive keys, secrets, some GitLab secrets, some rsync secrets, and I think also SSH keys. So I could have used this to pivot to other assets, but I did not do that because that would break the rules of engagement. They have, if I break this, I will be banned from their program. So there. So once that's done, I've submitted my vulnerability report, and yeah, I'm waiting for reward. So yeah, that's it. Thank you.
This is a PSA to use a ortholinear keyboard. Yeah, I put this down, put this down and pass it around. So it's a keyboard that's not staggered. So if you move your fingers, it just moves up and down instead of moving it like weirdly. Yeah. So it helps with the wrist pain because you have minimal movement and there's less pain in your wrist because of that. So and the only downside is that like it's a very small, so there's a very little keys, and then you have to memorize all the key shortcuts. Yeah. So that's it. By the way, I'm I haven't introduced myself. I'm Eman, an underwater hockey player, and I feed myself by making Python desktop apps. Thanks.
I just want to ask, what are the buzzwords have you heard from the last 2 years? AI, blockchain, machine learning, big data, data science, and so on. But let's focus on machine learning. So for context, I'm learning machine learning and I just want to share my knowledge in machine learning. So basically, machine learning is a subset of artificial intelligence. So as you can see, machine learning, yeah. I have read a research paper about machine learning in which Arthur Samuel, a computer scientist, who popularized the term machine learning. So Arthur Samuel defined machine learning as a field of study in which it gives the computers the ability to think and learn without being explicitly programmed. Take note, without being explicitly programmed, which means it is part or characteristic of artificial intelligence. Now, there are different kinds of machine learning. First, supervised learning. We train our data with an input and it produces an output. Typically, the input that we provide in our model are compiled in a CSV file, typically in Excel form. You can do regression and classification. One example of regression is you can predict the house price using the features like the room, the size, and so on. Next, classification. This typically involve in medical healthcares. For example, if you want to predict whether a patient has a cancer or not, you can use classification model to predict its problem. Next, unsupervised learning. Here, we don't have an input to provide our model. The output is your model guess the output. So, for example, I don't have any input and I ask my model, hey, is this an apple? Then our model, it's either it won't respond or it will say female. It's out of context, right? But this, in this process, we will train our model. Lastly, reinforcement learning. So I like reinforcement learning because the concept of punishment and rewarding comes here. For example, I have my model. Hey, is this an apple? If our model guess correct, then we will reward it by giving it a candy, or let's say $5. But if our model gives us a wrong answer, then we will punish it by, for example, I will give you a 5 years of life sentence imprisonment. So thank you for listening and machine learning in a nutshell. Thank you.
So yeah, I'm Andre Andresito de Guzman. I'm more of a self-taught programmer, but currently working as an engineering lead at the Outsource People. Yeah, so back in my journey, since, yeah, as I told you that I am a self-taught developer, that I did not have any computer at my disposal to learn about programming. The only thing I had was this small phone, which is probably 3.5 inches, I believe, back then, where I learned about programming. There's W3 schools before and stuff. So this is where I learned about the web, about Python. And what allowed me to um, do all of these are in Android, sorry. Oh, sorry, let's go back. There's an app called like Termux. Who knows about Termux? A lot, wow. Back in the day, it's like kind of niche, but yeah. So this is where I've learned about it. So basically, it's like a small Linux thing where you could like install packages, where you could run like your Python scripts, etc. So this is what I've used to run my Python code. And the good thing about this is that aside from just being a Linux shells, etc., it has an API actually that allows you to take advantage of the phone's capabilities like hardware, camera. So you know me as a PWA guy, some of you knows. But before that, I used to take advantage of the native functionality using Python, using all of these APIs. So you could use SMS, contacts using these APIs, right? So one of the ways for me to fully take advantage or learn about Python is to create projects that of interest. And one of those is what I did was to actually create like an SMS autoresponder where you like text help space something, it would respond to you. So that's one of the project I did 8 years ago. Sorry. So SMS Py, you can check it out on my GitHub. So basically, I use Termux API, especially the SMS thing there. So here's the code. Yeah, basically, I just use a process to call the Termux API, and then I just process the JSON file, etc. So yeah, right? So imagine using your old Android phone, right? As a small project to create servers. Imagine the amount of e-waste that you get to lessen by using Python, your Python code, and Termux to create a difference. You could create autoresponders, use its sensors to detect critical information, send it to a server that you have somewhere in the cloud, right? So yeah, just imagine all of this you could do with your Android device. So if you wanted to check out the code and some of the other things I did back then with Python, like I did before a Python script that unfollows the people that did not follow me back. So I did that as well because it's fun, right? The best thing to learn about Python is to have fun. So you can check me out on my on my GitHub, and yeah, thank you everyone.
Actually is I'm promoting the 5 projects of PCHRD, our Philippine Council of Health Research Development. They have 5 AI projects. Sorry, I don't have the presentation. I didn't prepare a presentation, but I'll just list to you the 5. The 5 AI projects that they have is, one is the COVID-19 data set and image recognition of the X-rays of it. And the second one, it's called Candle. It's granted to UP Telehealth. It's a liver cirrhosis dataset and how to recognize it through X-ray and ultrasound. The third one is the recognizing dyslexia. It's a computer vision problem. So there's a doctor, I forgot his name, sorry, that is making an AI, computer vision AI, to recognize if a particular individual is dyslexic based on the handwriting. And then the fourth one is an automated food recommender that uses AI to recommend nutritious food. And the fifth one is a nutritional assessment tool, to AI nutritional assessment tool that uses computer vision to recognize the food, and then from recognizing the food, estimating the weight just by looking. So that's the 5 projects that I want you to look forward to, that is being made by our scientists and AI people that are funded by PCHRD. That's all.
Hello, good afternoon. Yan. Hala, walang energy. Good afternoon. Yeah. And so, hi everyone. My name is Faye Andal and I'm representing UP Resilience Institute. So I work with Chris, yung nag-present about the earthquake system kanina. So what I will be presenting now is a system that we built on UPRI. So this is called the impact-based flood forecasting system here in the Philippines. And who here is familiar with the NOAA website? Have heard of it before? Oh, ang dami. Yay! Ayan. So, Project NOAA, if hindi nyo masyadong kilala yung NOAA lang. So, we used to be called Project NOAA, which was a project under the Department of Science and Technology. And we've been building or modeling hazard maps and deploying it on our website. And now we've been focusing more on extending the layers of our map into different parts like exposure mapping, risk mapping, so that the government can also use the map data. And most of our tech are built on Python. So, syempre, we use GeoPandas, all of the libraries under the GDAL hood. So, we've been using those to deploy or build our end-to-end data processing and analysis systems. And yung recent feature that we have is the impact-based flood forecasting system, which basically aims to empower local government, since sila talaga yung target users or stakeholders for this kind of system. And what we do is to forecast kung aling barangays yung tatamaan on a certain flood event based on a specific amount of rainfall. So it can help communities na mapaprioritize due to that kind of flooding and how much flood will they be experiencing, and therefore allocating more resources for those barangays that will be affected. And this is how the system currently looks like, and it's actually part of a bigger consortium project which is funded by the USAID, and we've been working with the Tufts University and other universities across the world for this. And this is how the feature looks like. So we have basically the rainfall forecast from a global forecasting model and then recalibrated into local, depending on the local weather conditions here in the Philippines. And from this data set, syempre meron kaming processing to know kung alin yung barangays na magiging prone to that kind of rainfall event na makaka-experience ng specific flooding. And aside from the map visualization, we also produce a list of barangays that will be affected by that certain event or flood event. And pwede ding malaman dito yung ilang population, ganyan, and how much percentage of that population will be affected by a certain flood hazard. And ayan, some maps to show alin yung mga areas na may population. And how do we validate actually the system? So we've been using or utilizing social media reports to know if meron talagang baha dun sa lugar na yun. So from the results of the system, tinali namin kung asan yung mga areas na yun, and then we searched on them on Twitter, on Facebook. And we've been getting accurate results naman. So for example, yung recent was the January 30 rainfall sa Davao Oriental, sa Davao area. And marami kaming nakitang reports from the social media na nagpo-prove talaga na correct yung system na nalalabas ng models namin. So yan, some photos lang to show what it happens on the ground. Ayun. So this is our team. So syempre, if you know Dr. Lagmay, he's the one involved rin in this project. And some of our team is also here, so si Ate Bon. And yeah, we also have a consultant for the rainfall forecast. So if you want to contact us or collaborate with the UP RI team, you can just email us on yeah, in this platform. So yun lang, thank you.
Sorry, mas matagal pa setup, ads lang to. Ah, I just wanted to let you know about this website kasi a lot of people don't know about it. PyCon APAC website. Uh, Mapupuntahan nyo siya sa, you can go to this website by typing pycon.asia. And then, why is this website useful to you? If you've enjoyed attending PyCon today and yesterday, I'm happy to let you know that there are other PyCons in Asia. And these are you can find all of them, the event dates in this website. For example, on in August there's Malaysia, and in September there's PyCon Taiwan, in September PyCon JP, PyCon APAC in Indonesia in October. Then I think the tentative date for PyCon Korea sometime later. So I also just wanted to let you know that the next PyCon APAC 2024 will be in Indonesia. Is Dima here? Ayun lang. Attend kayo if you've enjoyed this and you like traveling. And also, this website was contributed by PythonPH. Ayun lang. And if you also wanted to improve yung UX, ano na lang, paki-ping na lang ka. Yan lang.
So, hi everyone. My name's Arnel. I'm from Davao City, but I work as a Python backend engineer at a fintech company in Australia. So about late last year, I was like given a task to create a document automation pipeline. So what we did is that our company builds SaaS products that helps financial advisors give better advice for their clients. And one of the features is that we collect their data on our digital forms and generate PDFs, legacy PDFs that are being used by the financial banks. So what we're gonna go through here is just a walkthrough of how I did that. So yeah, what is the challenge of building document automation pipelines? Well, first, it's the technology. PDFs are like a very old technology originating from Adobe. So they use this technology called Acroform, which is their way to insert check boxes, text boxes, radio buttons, and drop-down lists into your average PDF. So there are open source libraries that help you do this in Python. However, those technologies are so legacy that it's hard for them to parse the legacy encoding of the PDFs, like the checkboxes, the radio buttons, and whatnot. So that was the issue for me when implementing that feature. So after that, after I figured it out after a few weeks, I made it into a Medium article, which I'm just gonna walk through here. And yeah, in this demo, we're just gonna use PDFtron, serverless framework, and yeah, AWS. So yeah, first, I'm not sure about the projection, but yeah, first we're just gonna create a function to like extract the forms in the PDF. So after that, you'll get a schema like this. I'm not sure if you can see that. If you can see, there's a name, the address, a drop-down menu, and you can see that there are strings. Once you get that schema, you can turn it into a JSON body for your API request. And from there, we can just turn it into a post request in our serverless framework schema. And right here. And we can just put it together with our Lambda handler, which just pulls the template from an S3 bucket, does the parsing with the PDFtron handler that we've created, puts back the generated PDF back into S3, and creates a DynamoDB entry for the user ID and the location of the S3 bucket. And after that, you can just get the response with the user ID and the location of the S3 bucket and just download it with your usual S3 downloads. And yeah, if you're looking into implementing serverless document automation pipelines, you can just look into PDFtron and serverless framework with Python. That's all. Thank you.
I am Maded Batar III. So my organization is the Computer Professionals Union. So if you guys have heard of it, it's an organization of ICT professionals that essentially use their skills, use their technological skills to provide projects that really directly impact the grassroots, which I think is related to what we discussed yesterday by Dr. Reina Reyes, right? And how she uses her expertise to really impact those at the grassroots. So this is a talk, not really, I mean, a bit to plug, because if you guys want to join, it's open to everyone, both students and professionals. Feel free to just, we'll be there at the open space later. But I also want to talk about what specifically we do in CPU in our organization. And we'd want to kind of like create one, highlight one specific project, which is Vote Report PH. So who here voted in the last election? Right. How did you guys find it? Was it like a good experience, a bad experience, an okay experience? I think a lot of people had issues with, for example, their machines breaking down, or maybe, you know, lots of long lines, etc. And we wanted to catalog that. We wanted to concretely see the situation of elections in the Philippines, for example, what the specific incidents. And the only way we could do that is really to crowdsource data. So this is data science in the form of actually mobilizing people to directly provide data to you. Okay, so that's it. That's citizen-generated data, but I'll just skip over it because I think we know a lot about data already. But this is just the form of data where we directly collect from the people, right? This is not just data science in the aspect that we analyze, but we also encourage people to actually give data to us, which of course introduces a lot more challenges. And that's what our project Vote Report page aims to solve. So actually we developed it not just within CPU, but we had some allied organizations, for example, PWA Pilipinas, Andre, hello, helped us develop this platform, which essentially enables people to report and also enables mass of volunteers to filter and categorize and really label all reports from across the Philippines in order to create summary statistics over what exactly happened in the elections in the Philippines. So for example, this was our final report last year. So we had around 3,000 verified reports from all over the country. So we mapped it right here. So that's just all of the report of the machine errors, electioneering, lots of black propaganda outside polling precincts. So we gathered around 2,700 reports. So that's, I think, the most reports that we've had since this project was set up in around 2010. Okay, so we gather data from various sources. So for example, we gather data directly from social media, but we also aim to get verified reporting by partner organizations that do monitor election reports on the ground, so a bit of more verified reports. And then we just converted it to a common format to be fed into our system. And then volunteers, so this is not automated, but these are actual volunteers, both on ground and online, who actually filter the reports for any duplicates, categorize them, label, add appropriate data so that they can be geolocated and so that we know who is involved, and then have a final processing step before we actually publish it to the public. So for example, from around the 6,000 reports that we actually got, half of those we cut out because of our team of volunteers. So we release regular bulletins. So there's also a communication component here, a visualization component. We don't just process, but we also want to inform the public as to how exactly the reports are going on throughout election day. So it started off with Ushahidi, which is a PHP-based platform, but we upgraded it in 2022. So there's a front end for the processing using TypeScript and Angular, but the actual processing we did using Python. So just so since we're at PyCon, there has to be a mention of Python right there. So yeah, so we did get it's a difficult it's really difficult to gather citizen data, mainly because there's a lot of noise, and you have to filter those noise. But what we really learned here is that we do need a lot of people. You do need to mobilize a lot of people in order to be able to filter and categorize those data by yourself. So there, if you guys want to volunteer, catch us later at the open space right there. If you guys are interested, feel free to ask us more since we only have a few minutes here. And yeah, thank you very much.